we've got 3 different instruments with a sine wave playing the note F4. So on the right hand side, the frequency scale I'm using is called MEL, which I find to be a lot more readable as the frequency curve is a lot flatter. The ear actually perceives frequencies in a logarithmic sense as displayed here. And if we select linear, this is the most basic view where we can have the frequencies increasing by increments of 1 kHz, which is quite an unusual curve. The Harmonic Series is what you'll notice here with these stacks of frequencies. And we have the note F4 playing as the fundamental frequency. If I start from the right, by looking at the sine wave, you can see that this selection is fundamentally one frequency. It is a pure frequency with uniform amplitude and it is unchanging. The glockenspiel has a fast decay of harmonics, decaying in less than a second. This instrument is designed for the upper register, so we have these bright overtones. The fundamental is actually an octave higher, so it would be F5. Before I get into the clarinet, I just need to match the gain of the violin here. So because this is a woodwind instrument, it's going to produce a very solid uniform level due to the air pressure from the reed at the mouthpiece. The variation, of course, is subtle in the harmonics, but the average level is very consistent. In the onset of the sound, we can hear the low frequency being excited first with the breath. And as the sound continues, it becomes brighter with more harmonics. This is related to the air pressure building up, and it happens rather quickly. With the violin being a stringed instrument, it generates all harmonics. The sound is excited by the hair on the bow, generating friction on the strings. This gives a lot of variation in the harmonics and the amplitude. On the higher harmonics, you can notice a slight vibrato happening. To really focus on the loudest harmonics, I can go to the spectrogram settings by right-clicking on here. And I'll just take the lower limit to about 20 dB dynamic range. We can see that we're left with the loudest harmonics. I'll just boost this a bit. What is interesting is just looking at the first 2 instruments is you've got the stringed instrument generating all the harmonics as though on a flatter plane. With the wind instrument, we have a more hollow sound with these odd harmonics. Now I'll just select these harmonics actually by selecting the fundamental and then counting each. So 1, 3, 5, 6, and 8. These are the loudest harmonics at this point. I can actually just play this selection. Isn't it surprising how we can identify the instrument very well with only a few frequencies? There are only 5 frequencies that we can hear. Similarly, I could select the same with the violin and we will have a very similar sound to the clarinet. But of course, there is still too much variation to really expect a woodwind sound from this. Another thing that I find fascinating is that we've only analyzed the spectrum of one note per instrument. If we analyzed every note, then we'll visually reveal the incredible dynamic in musical instruments, especially the upper and lower limits of the instrument. Looking at these instruments in A6 illustrates why the clarinet sounds more like a stringed instrument. And the glockenspiel fundamental decays about 4 times as fast than in F4. The spectrum of the violin is very consistent, but the sine wave remains identical. And that is why there is a method of synthesis called physical modeling, which looks at all the physical properties of the given instrument. There is an incredible amount of detail and mathematics that needs to be investigated. After all, sound exists first in a physical form and the instrument possesses physical characteristics. With additive synthesis, we are focusing on merely the harmonics, and that's why when we play the note at a higher or lower register, we notice that the instrument begins to sound fake and unconvincing because there are other physical properties of the scaling that are not applied. This is one reason why key scaling becomes so useful.